Welcome to this explainer. You know, every time you turn a key, or I guess push a start button nowadays, you are literally waking up over a century of relentless human innovation. Today, we're tracing the incredible 138-year journey of the machines that quite literally drive our daily lives. Let's look under the hood. So, how exactly did we get from a sputtering single-cylinder motorized carriage to hyper-advanced electric grids rolling down the highway? Well, we aren't just talking about moving from point A to point B faster. We're looking at a massive story of mechanical ingenuity, shifting societal needs, and ultimately a complete rethinking of what it means to generate power. To make sense of it all, here's our roadmap. We'll be moving through 5 distinct eras, starting with the pioneers in 1886, the shift to mass production, that mid-century power obsession, the clean revolution in the late 90s, and finally, the modern synthesis of today. All right, part 1, the birth of the engine and the pioneers. To really understand these early pioneers, you have to realize speed absolutely wasn't the goal. Just moving forward without a horse was a total miracle. Looking at the 1886 Benz engine, it is just so raw and industrial. You've got these crude exposed chains, a giant heavy flywheel, and open brass oilers. This single-cylinder 4-stroke engine, meaning it took 4 distinct steps of a piston just to turn fuel into power, produced less than 1 horsepower. It was basically modified factory equipment bolted onto wheels. Moving right along to part 2, mass production takes over.
Because that early Benz design was completely bespoke and really difficult to run, the engineering challenge had to shift. They needed to focus on reliability for the masses. Enter the 1908 Ford Model T. Notice the immediate difference here. It's fully enclosed and relatively compact. By casting all 4 cylinders into one single solid block, Ford made it incredibly cheap and fast to manufacture. This specific design didn't just change transportation, it literally put the entire globe on wheels.
Fast forward to 1927, and the Ford Model A engine shows us how this concept really matured. It's so much cleaner and robust. They neatly integrated the water pump and cooling fan right at the front and popped the distributor straight on top for really easy maintenance. Why does that matter? Because this user-friendly, standardized architecture cemented the gas-powered engine as the undisputed king of the road for decades to come. Which kicks off part 3, the golden age of power and the pursuit of speed. Well, once reliability was conquered, human nature kind of took over, right? Basic transportation just wasn't enough anymore. We wanted raw, roaring speed. Enter the 1955 Chevrolet's small block V8. Just check out that wide stance and those prominent chrome valve covers. This thing was explicitly designed to look intimidating even when sitting entirely still in a parking lot. This engine democratized high performance, giving the average consumer their very first taste of real muscle. But man, did that pursuit of power escalate wildly. If you put that utilitarian 55 Chevy right next to an exotic 1966 Lamborghini V12, it visually captures just how fast things escalated. In basically a decade, we went from practical, accessible power to absolute, uncompromising extremes. The leap is just staggering. The sheer complexity of this Lamborghini V12 is almost comical. Right on top, you've got 6 twin-choke carburetors, which are essentially massive mechanical lungs, just aggressively shoving air and fuel into 12 highly tuned cylinders. The volume of fuel this machine inhaled is mind-boggling. It's a masterpiece of mechanical art, absolutely, but it also proves that by this era, fuel efficiency had completely vanished in the rearview mirror. 111. It took exactly 111 years from that very first Benz engine in 1886 for the automotive industry to collectively wake up and realize that this endless pursuit of gas-powered combustion needed to evolve. The environmental impact and the limits of fossil fuels were just getting impossible to ignore. And that brings us to part 4, the clean revolution and electrification. This is where the entire foundation of automotive propulsion gets rewritten. The engineering philosophy flipped completely on its head. The 20th century mantra of more fuel, more cylinders transformed almost overnight into a 21st century pursuit of more volts, more efficiency. We traded a loud mechanical arms race for a hunt for silent, optimized, sustainable power. The contrast here tells the whole story. On one side, the purely mechanical 66 Lamborghini. Total chaos and raw fuel delivery. On the other side, the 1997 Toyota system. We go straight from beautiful mechanical excess to tightly packaged, computer-controlled electrified precision. When you look closely at that 1997 Toyota Hybrid, it perfectly bridges these two worlds. You see a traditional gas engine physically bolted to a revolutionary electric drive system. Those bright orange high-voltage cables are the giveaway. It was a genius compromise, really. It gave drivers incredible electrical efficiency without the range anxiety of losing the convenience of the gas pump. And then the 2012 Tesla comes along and completely throws the combustion engine straight in the trash. This became the new paradigm. A sleek electric motor paired with a massive, flat, skateboard-style battery pack. No spark plugs, no exhaust manifolds. It's simplified, it's silent, and it relies entirely on electromagnetism. Plus, by putting all that heavy weight flat into the floor, it completely revolutionized how safe and spacious a car could actually be. Finally, part 5. Modern hyper-engineering and the synthesis. But the story doesn't just end with pure electric vehicles taking over entirely. Modern engineering has found a way to synthesize the absolute best of both worlds. Today's hyper-engines combine the visceral, roaring power of traditional fuel with the instant, clean torque of electric motors. They're pulling mechanical lessons from the V12 era, integrating electrical efficiency from the EV era, and wrapping the whole shebang in aerospace-grade carbon materials. Which brings us to the breathtaking climax of our journey. The 2024 Mercedes-AMG engine. I mean, just look at this thing. It's a carbon fiber-clad masterpiece. See those high-voltage components labeled MGU-H? That stands for Motor Generator Unit Heat. It literally captures wasted heat from the exhaust and turns it into electric power. That is straight-up Formula One racing technology built for the street. This is 138 years of human knowledge compressed into a single, devastatingly efficient power plant. So looking back at how incredibly far we've come from that crude 1886 chain-driven carriage to a carbon fiber hybrid hyper-engine today, I've got to ask, considering the explosive rate of our technological evolution, what unimaginable machine are we going to be explaining a century from now? Thanks for joining me on this explainer, and keep learning.